So this is better then? Excellent. Okay, we'll go with this then. So happy Friday. We're through our, back to chemistry, sorry. We're through our first full week of classes. Today on the docket, I want to finish up our discussion of the functional groups. And I should mention a couple things, by the way. These are by no means the only functional groups. I think I'm going to mention every one of them that's in the chapter. I might have forgotten a couple of them, but there are dozens and dozens of other functional groups besides these. I'm going to mainly focus on the ones I think we're going to run into the most, you know, the ones that you'll find in biological compounds, in pharmaceuticals, in the precursors for things in the materials fields or things like that. So we'll focus on those. We need to get through the carbonyl containing functional groups, although I think, and I'll also mention a couple that contain sulfur that especially get mentioned in the area of proteins and polypeptides. So it's worth it for you guys to have heard of these. When we're done with that, we'll go into naming alkanes, which is, I always feel that the only thing that could possibly be worse than lecturing on naming alkanes is listening to someone lecturing on naming alkanes. So I'll try to spend at least enough time on it. I'll just let you know that in your class notes for now, this is chapter 2. Gosh, chapter 1 is so long in your book. Holy cow. But in the chapter 2 class notes, I've given you kind of a step-by-step method that you can use to name alkanes given the structure. It's not the only way to do it, but you know, feel free to take a look at it. Feel free to use it to get started. Oh, one other thing. I actually heard some of the audio from my videos the other day, and yeah, it sounds pretty dreadful with the mask on my face. Rules are rules, and I intend to follow them. I have ordered a face shield, and I don't know if it'll come in as soon as the weekend. I hope it does. So I don't know if I'll have it as soon as Monday. As soon as I have it, we'll try it out in class, and we'll see if it's any better. In really all of my classes, I've become aware that there's some people who can't hear very well and kind of rely on reading my lips, which this is, you know, you can forget that. I will say if you need some help via things like subtitles or captions, now Zoom itself allegedly does closed captioning. And from what I've heard, from what I can tell, it's all right. It's not wonderful, it's okay. But the good news is I'm nearly positive that YouTube also does automatic captions. And I've heard that theirs are actually pretty good. The only things that I'm sure YouTube will fail on are the scientific words, you know, can't very much be helped. But as soon as, yeah, all the class notes should be on eCampus. I believe so anyway. Good, so, but yeah, until, I'm afraid that we'll have to do until we can get the face shield in, which I will need to try it from behind the thing over here. I also, here I'm just thinking out loud, I'm trying to plan ahead. There's gonna be sometimes coming up pretty soon where I'm gonna be manipulating molecular models. And I kind of think for that, I'll want to just flat out approach the camera so that everyone can see it on the screen what I'm doing. At that point, I guess I'll have to revert to the mask or things are gonna get really complicated. But that's just you know, it is what it is, right? So anyway, we covered, maybe roughly half the functional groups the last time, maybe slightly more, somewhere around them. There is a set of other functional groups that contain in turn what's known as the carbonyl group. So it's not carbonyl and it's not carbonyl, it's carbonyl. And a carbonyl group is just defined as C double bond O. And the two other bonds to carbon can vary. They can vary pretty widely, as you'll see. And that will tell us what the specific functional group is that we're talking about at the moment. Now, I only mention this, you know, someone will ask, and it's a perfectly fair and perfectly reasonable question. Someone will ask, is the carbonyl group itself a functional group? Kinda, maybe sorta. The way I would like you to think about it, though, is that the next two functional groups we cover certainly will be functional groups, and they will be ones that contain the carbonyl group. So I would not think in terms of your saying that a compound is a carbonyl. You would instead say the compound itself is a ketone or an ester or whatever of those carbonyl-containing functional groups it happens to be. All of those functional groups have a carbonyl in them, just so that we have a name for that C-double bond O linkage. But the functional groups themselves, you're always going to want to go with the most specific term you can, if that makes sense. So first one I'd like to cover is the aldehyde functional group. Funny word, A-L-D-E-H-Y-D-E, aldehyde. And I would define an aldehyde as a carbonyl group that for sure has a hydrogen attached to the carbonyl carbon. So my definition of aldehyde might look something like that. This group R could be either another hydrogen or an alkyl group, a hydrocarbon group, and that can vary. So the first, I would say the simplest aldehyde of all is a compound you've no doubt heard of. It would have just one carbon. And it would look like this. That compound happens to be formaldehyde. I don't really care if right now you memorize all these names, but I think you have heard of formaldehyde. You've probably encountered it in biology lab dissection experiments. Boy, long ago as that was for me, I still remember that smell. And I mean, other aldehydes tend to smell like that too, with one notable exception, which we'll get to. But other than that, this group can also, you can put any old alkyl group you like. By alkyl group, I mean, whoa, I nearly crunked that up. CH3, CH2. So this would be a 4-carbon aldehyde. You can call that compound butanal if you want to, or don't. I don't really, we're only going to name alkanes for now. We'll learn a little bit more about nomenclature later. I just mentioned in case anyone's curious, all of these things have names. Wait, oh, I lied, propanal. Sorry, it's 3 carbons, right? So, so that would also be an aldehyde. Do be aware that, of course, it could be pointing in the other direction. I don't want you memorizing that it's always the same atoms looking exactly the same way, put in exactly the same relative location. You know, I wouldn't put it past Owl. I wouldn't even necessarily put it past me to have it on the other side of the molecule. Here I've made the R group a benzene ring. And that is the only exception, or most notable exception I can think of, in that that compound happens to be called benzaldehyde. Again, I don't care if you memorize that. But as it turns out, for some reason, unlike formaldehyde and acetaldehyde and all these others, this stuff smells very pleasant. I have no idea why. People do disagree on what it smells like. Some people say maraschino cherries. Other people say it smells like almonds. But pretty much everyone agrees it smells very nice. Who knows why? It's the shape of the molecule and the shapes of the smell receptors in your brain. Who knows how all that works? But for some reason, benzaldehyde smells really nice. Most other aldehydes smell like formaldehyde, really disagreeable. Good, so much then for aldehydes. Next one I'd like to cover is the ketone functional group. And spelling pet peeve number 2, not that I suppose I'll ever be grading your spelling directly, but just to make me feel better, there is no Y in ketone. K-E-T-O-N-E, please and thank you. I get that a lot. It looks like a 50s band, you know. Ladies and gentlemen, the ketones. No, there's no Y in ketone. And ketones are kind of similar to aldehydes, except on either side of the carbonyl, you've got two hydrocarbon groups or two alkyl groups. We can call them R1 and R2. And R1 and R2 can be either the same or different, doesn't matter. But they do have to both be alkyl groups, and I think you'll see why that is. Actually, I'm having a deja vu experience because we just did this in Chem 227 also. You'll have noticed that sometimes these R groups can be hydrogen and sometimes they can't. But I think you'll find if you look at it with an open mind that that's not an extra thing that you have to memorize separately for each one. Because if you can imagine that either one or the other of these R groups is a hydrogen, well, then you don't have a ketone, you've got an aldehyde then, right? You see how it falls in the definition of aldehyde? So I don't think it's an extra separate thing that you'll need to memorize. In order to be a ketone, we do need these to both be alkyl groups. And so the simplest possible ketone that you can get has 3 carbons, in which both of those alkyl groups are methyl groups, which is CH3. And you can't get a smaller ketone than this. Again, my understanding is some of you are taking lab and some aren't. Those who are taking lab will probably get to encounter, that stuff happens to be called acetone. You might have heard of it. You'll probably get to encounter acetone. We use it quite a bit to wash glassware with, and also just as a solvent. And I mean, it's pretty benign. I wouldn't go drinking it. I wouldn't go taking a bath in it, but it's fairly benign. The worst it'll do if you get it on your skin is it'll kind of take the oils off the surface of your skin for an hour or two. But it's not really bad. But that's just the simplest one. The R groups attached can be arbitrarily long chains. Let's go crazy here. I don't know, some nonsense like this. And you can see the C double bond O here, here's the carbon and kind of a line angle thing. You can write a letter C there if you like. It's not wrong. You can. But you don't have to. It's also understood if you don't. So that would also be a ketone. And I would expect you to look at that and say, I have no idea what that godforsaken thing is, but it is a ketone. You don't need to know. I don't know really anything else about it. I might be able to name it if I really put my mind to it. It would be pretty ugly, but certainly for sure we can all agree that's a ketone. Good. Any questions so far? Since I've used the same stupid joke in my other 2 classes so far today, you mean I'm such a good teacher that was so clear that no questions are even possible? I wish. In my dreams, maybe. Okay, let's now do the carboxylic acid functional group. And all of these we're going to talk about more at length at some point in the term. There's a chapter in carboxylic acid, there's a chapter in alcohols, a chapter on, ketones and aldehydes. So little by little, we'll fill in the information. And we'll say a little bit about nomenclature also at each point. I'm not going to dump all the nomenclature on you right now. The alkanes is enough for now. And by the way, please forgive me if I've said this already because I've had similar subjects in my other classes. The great thing about learning how to name alkanes is once you know that, 85%, maybe even 90% of what you need to know to name anything else. So once you get that down, the rest is fairly straightforward. Anyway, the carboxylic acid functional group is also a carbonyl-containing functional group. And I would define it as RC double bond O, OH. And again, that's an electron, though. Goodness, you'd never know it. Be prepared, of course, for that to be flipped around on you, H, O, C double bond O, and then the alkyl group. But that's the general form of a carboxylic acid. R can be either hydrogen or an alkyl group in this case. Whoops. So the smallest possible carboxylic acid happens to be called formic acid. It's where R is a hydrogen. It is just 1 carbon. just like formaldehyde formic acid. You know, it means it is one carbon. And that stuff you will find in bee and ant venom. So if these things sting or bite you, it's extremely irritating stuff. You're probably more familiar with acetic acid, which is a 2-carbon carboxylic acid. That, of course, is a component of vinegar. Pretty much any type of vinegar you will get off the shelf is probably going to be around about 4 or 5% acetic acid. So that's the 2-carbon. But again, this R group can be arbitrarily huge or somewhere in the middle. It can be anything at all. If it's a benzene ring, then you got benzoic acid. I don't care if you know if it's called that, but that does exist also. So there's all kinds of other possibilities here. 5 carbons, 6 carbons, whatever you like. But this part is invariant, C double bond O, OH. Oh, and I do need to say another thing. Please note that carboxylic acids are not alcohols. And the way you know they're not alcohols is we defined alcohols such that the carbon that's attached to the OH needs to be a hydrocarbon carbon, needs to be an alkyl group. And this is not a hydrocarbon carbon, it's a carbonyl. So that's how you know. So carboxylic acids and alcohols are different critters. Oh, sure, they have some things in common. You know, the OH group does bring some features along with it. But they do have quite different reactivity, not 100% different, but quite different. Main difference being, as you will probably have already guessed, carboxylic acids are a good deal more acidic than alcohols. They're much stronger acids, but they are not the same thing. Carboxylic acids and alcohols are not the same thing, and that's how you know which is which. You look at the carbon that's directly attached to the OH. If it's a carbonyl, you've got a carboxylic acid. If it's an alkyl type carbon, then you've got an alcohol. Okay, let's see. I can think of at least 2 more. I just want to be sure I don't miss anything. The ester functional group is somewhat similar, and that brings me to my 3rd and last pet peeve. There is no H in this ester. This is not the biblical ester. E-S-T-E-R, please and thank you. And you can think of an ester as being an addition product or a combination product that you would get by treating a carboxylic acid with an alcohol. And we'll learn that later on. We'll learn about that reaction when we get to the chapter on carboxylic acids and esters. That's near the end of the semester. So an ester would look something like this. And the way this works is R1 can be anything, hydrogen or an alkyl group. So 4-made esters are possible. And the only restriction in R2 is it can't be hydrogen. And again, I don't think you'll need to memorize that separately. Think for a moment, if R2 is hydrogen, you don't have an ester any longer, now you have a carboxylic acid. So it's not an extra arbitrary rule that you need to memorize. I think if you think on it for a moment, you'll see it kind of makes sense. So the simplest ester would have just 1 carbon here and maybe a methyl group over here. One ester that you might be quite a bit more familiar with is, well, I mean, you might have run into it. The only one I can think of that's used, that's reasonably small and is used in quite a few consumer products is this one. It's the ethyl ester of acetic acid, otherwise known as ethyl acetate. And you can find ethyl acetate in your paint thinners. I'm pretty sure nail polish remover has some ethyl acetate in it. But again, this alkyl group can be arbitrarily large or small. This one can also be arbitrarily large or small. Benzoate esters exist, absolutely. You can have a benzene ring. I'm just trying to think of some examples. OCH3. You can call that guy methyl benzoate or not. You know, we'll learn how to name these things later when we actually get to those functional groups. Or this methyl group could be a longer chain also. But that's what we mean by an ester. And I think the last one in terms of carbonyl containing groups is going to be our amide functional group, A-M-I-D-E, amide. And organic chemists pronounce it amide, biochemists pronounce it amide. And organic chemists are right and biochemists are wrong. But anyway, This is really a closely related thing to the amines. You can maybe even tell from the name, it almost looks like it says amine. And I believe I said the last time I'm pretty unhappy with how amines are usually defined in organic textbooks, and yours is no exception. But I think the best way to define an amide is that you've got a carbonyl with an R group on one side and a nitrogen on the other. And just like in amines, these two other bonds to nitrogen can be either hydrogens or carbons, doesn't matter. This group R likewise can also be either a hydrogen or an alkyl group. So I guess the smallest amide would be H, C double bond O, NH2. That stuff happens to be called formamide. Well, I think you can already see the pattern. Formamide, formic acid, formaldehyde, all these guys have just one carbon. But again, you can build this up however much you like. And CH3, CH2, CH3. So just like with amines, these two bonds can be either to two hydrogens or one hydrogen and one alkyl group or two alkyl groups, doesn't matter. In any of those cases, you've got yourself an amide. And I would say the reason amides are kind of important, really a lot of these functional groups are going to show up with proteins, but amide functional groups especially, the peptide bond is an amide functional group, period, full stop. So these things are going to turn up later when we get to the biologically relevant compounds. Yeah, and I think that's about it. With that, we're kind of done with the carbonyl groups, or carbonyl containing groups. I believe I've already done alkyl halides. I want to do nitriles and the two sulfur containing ones that I think are at all important, thiols and sulfides. So any questions so far? Yes. Right, all of these that we've done so far today contain the carbonyl group. So you could say they are carbonyl containing functional groups or something like that. Yep, that's correct. Yes. Well, that's just it. Remember, I really, and I don't know how official this is, but I consider, the question is with these, for those in chat, are these also alkanes? I would say no. Even if you can find an alkyl group in a molecule, the presence of even one other functional group makes it no longer an alkane. To me, the term alkane implies a total absence of functional groups. Since if you even put in a double bond somewhere, now you've got an alkene. That would count as a functional group. But yeah, I would not go marking alkyl groups as alkanes. This compound is an amide. R groups are only alkyl groups. Sometimes the R groups are alkyl groups, sometimes, oh, well, again, left side or right side doesn't matter. Remember, because I could just as easily have written that amide like this. See, that it's a common trap that I see students falling into, is learning how it looks only facing one direction. Please do your best to avoid that. It's an easy trap to fall into. I really have to invest in a stylus this weekend. The department got me a, what do you call that? A Microsoft Surface, and that comes with a stylus, but I don't think it'll work on this. I think I'll need a separate one. So, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So, same thing. So please do be prepared to identify functional groups no matter which direction they're pointing. And I'm sure Al will give you some practice on that. And by the way, I'm going to try to get up a few of my old exam 1 questions like early next week. I'm going to try to do it by, say, Tuesday. But we'll get it done. Good, so those are all of the carbonyl containing functional groups. At least if you hook up that service system, you'd be able to use it. That might be true. Oh, I'm sure you're right, I'm just kind of afraid. Well, maybe I'll try it. I mean, what could go wrong? I also have a laptop of my own, though I don't think, I know I've been complaining about this laptop, but honestly, I don't think this laptop is any worse than my laptop. It's probably even better. It certainly looks newer. Yeah, maybe we'll try that sometime, because then I can just draw right in the surface. You know, I think Mr. Drew Benson is a genius. I think I should do what he suggests. We'll try it. Maybe we'll try it Monday. But I may have to ask for their help on that. Good, so a couple more. One functional group that I don't think we'll run into very often, but we might a little, it's called the nitrile functional group. And nitriles are N-I-T-R-I-L-E, nitrile. And nitriles are essentially organic derivatives of hydrogen cyanide. So they contain the cyano functional group, C triple bond N. And so R can be pretty much any alkyl group, but again, it's evident R cannot be hydrogen, because then you have hydrogen cyanide, and that's not organic. So the smallest possible nitrile would be called acetonitrile. It has 2 carbons, CH3, C triple bond N. Again, don't fall for it if they draw the kind of mirror image of the molecule and put the nitrogen in the other side. Don't let that trip you up. But that would be an example of a nitrile. Repeat ad infinitum, replace that methyl group with whatever you like. And again, they don't see much use. Sometimes these things get used as synthetic starting materials, but I mean, I can't think of any, at least not very many, biologically relevant molecules that have the nitrile group. The only thing I can think of is there's some weird things that you find in apple seeds, peach pits, plum pits, all of these things. And they're called cyanogenic glucosides, which is a $600 word meaning that they're able to release the cyanide ion, which, as you know, is stupidly toxic. In an organic molecule, acetonitrile is, again, I wouldn't go drinking it, but it's nowhere near as dangerous as inorganic cyanide, because this carbon-carbon bond is quite strong. But, you know, depending on what else is attached to the carbon, you can make it so that it can lose cyanide ion. And so this is why peach pits, plum pits, apple seeds, etc., at some level are toxic. It's kind of like a natural protection or something like that to these things. It's also why I wouldn't go eating any of those things, although I don't think anyone was really looking forward to eating a peach pit anyway. It doesn't sound like a lot of fun. And I do want to let you know, by the way, because some people eat apples with the core. You know, if you do that with an apple or two, it's fine. It would take probably pounds and pounds of apple seeds to be a problem. Still, you might not want to do that too much, you know. Good. Okay, so much for nitriles. We then have 2 sulfur-containing functional groups. The first one is essentially the sulfur version of an alcohol. We call it a thiol, T-H-I-O-L. And instead of ROH, it's RSH. And pretty much everything we said about alcohols applies. The R can be any alkyl group. It does need to be an alkyl group, because if it's hydrogen, then you've got hydrogen sulfide, and that's not organic. So R needs to be at least a methyl group. Thiols, of course, stink to high heaven. You're familiar with skunks, and you know, they have thiols and sulfides in there. So anything where sulfur has an oxidation number of -2 is in general going to smell real bad. So anything where sulfur is in this kind of -2 oxidation state, reduced sulfur, you could say. But other than that, it's basically the sulfur version of an alcohol. Oh, and I think I did put this in the class notes. You might, so you can get the spelling there. You might also see these referred to as mercaptans, M-E-R-C-A-P-T-A-N. It's in the class notes. That's the older term. People mostly call them thiols nowadays. And then last but not least, if you can go from an alcohol to an ether, what if you change it up to sulfur? Can you do that too? Absolutely you can. And those are called sulfides or thioethers. But most of the time we call them sulfides. And you could consider that to be R1, S, R2, with exactly the same type of discussion that we had about ethers, except we've just changed the oxygen out for a sulfur. And that makes sense, right? Because sulfur is right below oxygen in the periodic table. So no big surprise, right? So in terms of the structure, sulfides are very similar to ethers. And R1 and R2 can be any alkyl groups. They cannot be hydrogen, of course, because if either of them is a hydrogen, then you have a thiol, not a sulfide. But these two alkyl groups can be the same or different. They need to be at least methyl groups. They can be arbitrarily larger than that, as large as you wish, and you'll have yourself a sulfide. Thiol functional groups are also going to become important when we think of proteins, maybe a little bit. I don't know how much we're going to talk about this. There's an amino acid that has a thiol functional group in it. It happens to be called cysteine. And so these things are connecting up with other SH groups, maybe hundreds of amino acid residues away, to form what's called a disulfide, which instead of R1SR2, it's R1SSR2. That's the oxidized form. And so those are your disulfide linkages, if you've heard about those in biology. They might have mentioned that even in high school biology. But so all of these functional groups do show up and have some importance. And as I think I might have said, there are dozens of other functional groups besides these. I don't think you're going to run into them too often. The only one that you might, if we ever need to talk about it, I'll try to mention it if we do. The only one that comes to mind is the so-called carbamate functional group, also known as a urethane. You might have heard of polyurethane resins. So if you're doing anything with polymers, with adhesives, maybe, and certainly you can always look up what that functional group looks like. It's another functional group just like all of these others. If you ever run into any other functional groups you need to know, you can treat them just the way we've treated these. But I really do think that these are the most common. And probably 50% of these functional groups will be the ones that we'll see 85% of the time, if I really had to guess. I think we're going to see a lot more alcohols than nitriles, by the way. Some of these just are much more common, in common use than others. Good, I think that's all I really need to say about functional groups. Please do practice, and please do hook up with my class notes, because I tried my best to make it clear in the class notes what it means to know a functional group. You already all know you're going to have to know your functional groups. That's no big mystery, you know that already. But unless I'm clear on what it means to know a functional group, which I think I have been in my class notes, you won't know what to aim for. So I've tried my best to help you. Certainly knowing a functional group, as I've already implied, means, among other things, being able to recognize it even in a molecule you've never seen before, no matter which direction it's pointing. I know you'll get questions like this on ALO that give you some big, tough-looking molecule with 8 functional groups in it, and say and tell you to identify them. And I would expect all of you to be able to say, I have no idea what this godforsaken thing is, but this is a ketone, that's an alcohol, and over here we've got an ester. That, I think, would be a reasonable question. So, and I think I said this too, but bears repeating, I suppose. In terms of, there is a table in your book. I do not recommend memorizing it. I don't think that's a good use of your time. I think dealing with these conceptually and learning to recognize them in all possible circumstances, that's going to be a lot more helpful than just memorizing the table. Certainly take a look at it. You might find it helpful. But I will say that merely memorizing that table is not the same thing as knowing functional groups. You need to be able to apply it. So, and you'll have ample opportunity in OWL. And speaking of OWL, so the only thing now due tonight should be the things that aren't graded, the intro assignments. I don't really know what due means if it's not graded, but take a look anyway. Let me see. I should have sent you guys an email talking about office hours tomorrow, and also mentioning that I'm going to be fixing up the Reef grade book, right? I maybe have said it in class already. I'm sorry. I have like all the same announcements in all 3 classes, and sometimes runs together. There's good and there's bad in being my last class of the day. The last class of the day is where everything's jumbled together. Thought it was, nothing is due that's graded until the 4th, right? Anything due tonight is not graded. Which, again, what does due mean when it's not graded? It's just the intro assignments. It should be that nothing is due that's graded until next Friday. So, good. So much for functional groups. Let's see, which means we finally thank goodness, have gotten out of chapter 1. So let's see, what we're mainly going to start off talking about is alkanes, even though there are compounds that essentially lack functional groups. We also basically consider alkanes to be what we build on to make any other molecule. So we kind of need to start with them and learn what their structure is like, how they behave, and also how they're named. And that's what we're going to talk about starting today. And again, I think we've already talked about bond angles and hybridization. Certainly we can discuss things like that in office hours if you like. It's covered in Gen Chem, so I just don't want to spend a lot of class time on it, but I think we've already mentioned quite a bit about that. Good, and I do mention in the class notes, you will need to know the names of the first 10 unbranched alkanes. And this is one time where you might almost want to memorize a table. I do try to avoid making you guys do that. But this might be, a question in chat is, are they going to disappear tonight, or can we work on them throughout the week? Since they should stay there for the whole semester. They shouldn't disappear at all. I believe I have it, so even with later assignments, you can always go back and practice. And at least that's what it should be. Certainly let me know if not, but I haven't heard any, well, I guess you wouldn't know yet. So, and after the deadline, also I should say, there's some assignments where you can see correct answers and some where you can't. You should be able to see all correct answers and hints and everything after the deadline. So you might have to wait till after the deadline, but in theory, that's what's supposed to happen. Now, the reports I get from students are mixed on that, but in theory, that's what it's supposed to be. Good. So you'll need to know the first 10 unbranched alkanes. The only, and it's not as bad as it sounds, the only ones that are irregular are the first 4, methane, ethane, propane, butane. Those are C1, C2, C3, C4. I think you've already heard of methane. Ethane might not be quite so familiar, C2H6. Propane, I think you've heard of, you know about propane tanks. And butane, you've probably heard of, it's used in things like cigarette lighters. And happily, after that, starting with 5 carbons, it becomes regular. It takes the Greek prefixes, penta, hexa, hepta, octa, pentane, hexane, heptane, octane, nonane, decane for 10. And actually, if you know that, you also know undecane for 11 and dodecane for 12. And honestly, if you know that, you get everything up to 19 thrown in for free. You know, tridecane, tetradecane, pentadecane. So really, up through C19 is no trouble. That being said, I have never needed anything more than about 12. And I would be shocked if you ever need more than dodecane. But so, you know, if you know through C10, then I think you know the vast majority of that. I will try to remember not to do any C11s or C12s. Even if I do, it's multiple choice and you'll see the answers, right? So there's always that. But I would be shocked if in any context you ever needed more than 12. I can't remember a time where I've needed to name a tridecane or a pentadecane. At least I can't think so. I can't think of one. So I'm sure it will be the same for you. I even said all that. Some smart person put that in my class notes for me. I have to thank that smart person later. Good. So I'll spare you, although I tried to put some kind of argument in my class notes as to why it's important to be able to name compounds. I hope that's kind of self-evident. We need a unique name for every possible compound so that people can communicate and know what it is each other is talking about. The due date says tonight it will likely disappear after the deadline. Shouldn't. If it does, I'll see what I can do to get it go back up, but I know certainly the ones that are graded, you're supposed to be able to practice after the fact. So it should stay there, but we'll see. We'll find out, won't we? Good. So with that, let's see. I hope I. Oh, good. And I mean, what do I have here? 10 minutes, 9 minutes? I mean, I wouldn't be able to go over everything anyway. So I wish I had time to go over. I'll try to do a few examples of naming alkanes. I will let you know, to me, I find going from, let me see, what's easier, going from the structure to the name or the name to the structure? It's easier to go from the name to the structure, I find. You may disagree. You'll get practice on both on OWL, and we'll do a few here. We've still got 9 minutes. We'll do some in class. But do refer to my class notes. I've got here a 5-step method that is basically summarizing the so-called IUPAC rules that you can use to name alkanes. It's not the only way to do it, but you know, you might find it helpful. Feel free to adapt it to whatever works better for you. And I'll just say also, the great thing is, once you can name alkanes, then naming, you already know everything you need to know to name alkyl halides. If you can handle 2-methylpentane, then you can just as easily handle 2-chloropentane. See what I mean? It's the same thing. To know one is to know the other. But let's at least do some examples here. Don't want to pick anything. Well, I'll pick a fairly small one to begin with. That's a good one to start with. Let's start with that one. And I'm just using line angle drawings because it's easier, but this would be CH3, then a carbon over here with 2 more CH3s attached, CH2, CH3. You can write it that way as well. So the thing says, first you need to find the longest continuous carbon chain, meaning that you can count all the carbons consecutively without lifting your pencil off the paper. And I think you'll agree it's 4 carbons. I don't think we can get a longer carbon chain than that. Otherwise it's 1, 2, 3, that's shorter, 1, 2, 3, 4, that's the same. Right, so I think that's the longest possible one. And in case you haven't already figured out that the OWL people are evil, they will not necessarily draw it for you so that it's the easiest possible to see. And I don't consider myself an evil person, but you know, I might stretch that far also. Things will not always be drawn for you in the most suggestive and easiest possible way. So it's good to practice finding the longest continuous chain, and we'll do longer than these. But with that having 4 carbons, that means it's going to be named as a butane, because the 4-carbon alkane is butane. So now what we need to do is number the carbons from the beginning to the end of the chain. 1, 2, 3, 4. Or 1, 2, 3, 4. One of those ways. And then we need to observe what alkyl groups are attached. There's no alkyl groups attached to this carbon, that's just CH3. Likewise, here it's CH2. This carbon has 2 methyl groups attached. Really it is 3, but the 3rd methyl group is part of the chain. So that's part of the butane. These 2 are not part of the butane. See how they're sticking out off of the chain? So we need to say that there are 2 methyl groups on this carbon atom. And so the way we would do that is we would call it, probably I think we would instinctively call it 2,2-dimethyl. Butane. And then we're done. Now this di over here means that there's 2 methyls, right? There's 2 different methyl groups sticking off of that carbon. And the reason we say 2,2 like that is because we have to specify they're both coming off of carbon 2. The only other plausible name would be 3,3-dimethylbutane, but we would prefer this one because in general, if let's say we come up with 2 names and we're not sure which one is better, and we'll maybe see, and I'm sure we'll see at least one other example of this today. You want to pick the one, this is also in the steps in my class notes, you want to pick the one where when you add up all of these numbers in the name, they add up to the smallest possible sum. So we prefer 2,2 to 3,3. So we'll go with the numbering system in the top one in this case. So that I think is the best name for that. 2,2-dimethylbutane. Let's, I want to pick one with a longer chain. Oh, well, any questions on that one first? Let me just see. Let's do a, you know what, I'm just going to make up a compound. I understood the first two, but why two twos? Because you need to say that both of the two methyls are on carbon 2. One of them might have been over here, then it would be 2,3-dimethylbutane. So that's why you say 2,2, because they're both on carbon 2. That's a good question that this person has asked. It's a common issue. Again, we say 2,2-dimethyl because repeating the 2 tells us that both methyls are on carbon 2. It doesn't have to be that way. This other methyl could have been over here. Number 4 is CH3. Yep, and that's just part of the butane chain. So we don't name that. That's included in butane. Let's do that. That ought to be, oh, no, let's not do that. Let's do that. I like that better. Oh, let's go nuts. Let's put an isopropyl group on. So if you somehow had 3 methyls in carbon, well, you can't though, then carbon would have 5 bonds. If you somehow did, that would be right, but you'd find it's impossible. But yeah, sometimes there are cases I've seen with, yeah, you've got the idea though, that's fine. Well, I wanted to make that a little harder than I did, I guess, but it's still pretty evident that this is the longest chain, 1, 2, 3, 4, 5, 6, 7, 8. So this is going to be named as an octane. Let me circle that for you guys. Or, you know, like that. So all those 8 carbons are included in the octane. I'm seeing a group over here and a group over here. And so I think you'll need to know your alkyl group names up to 4 carbons. I don't think you'll ever name anything as a pentyl group or a hexyl group. I just so rarely see that. But certainly methyl for 1 carbon, ethyl for 2 carbons. There's 2 different propyl groups. This is the isopropyl group because it attaches in the middle. And if it attached in the end, that would be an N-propyl. For N is for normal. And there's actually 4 different butyl groups, but the 2 most common types of butyl groups by far are N-butyl, which is just CH3, CH2, 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 that's just a straight chain, and tert-butyl, which is, it looks kind of like a cross. There's a central carbon atom, and then 3 methyls attached to that carbon. So those are the most common by far. You almost never run into sec-butyl or isobutyl. And as for me, I can never remember which is which. So it'd be kind of hard for me to put it on the exam since I can never remember which is which. But N-butyl and tert-butyl are much more common, and I think also much more important. Good, so we've got a methyl group here and an isopropyl group here. So actually now I'm regretting that, can I quickly change that to an ethyl group? Is that okay? That will make things a little easier. That will make my life easier. So now we've got an ethyl group on this carbon and an isopropyl on that one. So we want to number starting closer to the first branch point. That will make sure that when we get to the end, we'll have the smallest possible sum. So I think we should call that carbon 1, 2, 3, 4, 5, 6, 7, 8. So it looks to me like we've got ourselves an ethyl on carbon 3 and an isopropyl in carbon 4. So do we say 3 ethyl, 4 isopropyl, or 4 isopropyl, 3 ethyl? Answer, you go in alphabetical order. So we'll name the ethyl group first. Let me go back to black since it's easier to see. 3 ethyl, 4 isopropyl, oh, dash 4 isopropyl, octane for 8 carbons. And again, this to me is the more difficult direction, going from the structure to the name. I find that going from the name to the structure is easier. Yes? It's because it is 3 carbons, but it's connected to the middle carbon. That's what makes it isopropyl. So the definition of isopropyl is a carbon with an H and 2 methyls on it. Whereas if it were just CH3, CH2, CH2, that would be N-propyl, not isopropyl. So those are two possibilities. You don't run into that problem with methyl and ethyl because there's only one possibility for each. But with propyl, you've got two possibilities. With butyl, you've got four, but really I think only two of them. I think it's only the two of them that you'll run into, N-butyl and turf-butyl. The other two show up so rarely. Good, let's see. Any other last questions? Good, so do check my class notes for that. I've tried to leave enough information in there to help you guys out, but anyway, this is gonna be best learned by you guys practicing. There's only so much I can show you. You've got to get in there and practice. Good, so other than that, have a great weekend. We'll see you all on Monday.